Okay, wonderful. Then I guess we can get started. Thank you so much for your help setting up.
Enjoy.
And I'll see you later. Okay, so welcome everyone to the Transients and Variable Star Science collaboration session. This is not going to be the only session in which you will hear about transients, so I encourage you to look up the schedule. There will be other exciting sessions with people presenting their work, expectations, the science that they've made, all relevant to transient and the variable sky. My name is Igor Andreoni. I am co-chair of TVS along with Sara Bonito, who is now online and is kindly helping us by making sure that nobody's left out. So Sarah, please, if anyone from the remote participants post a question on Slack or here among the questions on Zoom, I would really appreciate if you could help us make sure that these are brought to our attention. So before leaving the floor to a few talks that members of the community will give and various updates that members of TVS will present, I would like, as always at the RCW, to say just a few words about TVS. Before actually diving in, just a couple of reminders. Any form of harassment and unprofessional conduct will not be tolerated. Please go look online or on any of these slides about resources in case you're a victim of bullyism or harassment, or if you witness it. There are some people that work as reference at the RCW for this sort of problems, in particular Sandrine, Andy, and Fed. Feel free to reach out to them. Respect people's social battery status. If people don't feel like talking, maybe postpone your reaching out and starting a conversation with them. And everyone's degree of comfort when it comes to physical contact, even handshakes and fist bumps. Just a reminder that people online will hear you only if you're speaking into a microphone. And something else that I would like to require is if you're in the room and you would like to make a comment, ask a question, please say your name first. I think it would be nice for the people online to know who's talking. And also feel free to contribute to the conversation using the online resources such as Slack as a primary method, as well as possibly the chat on Zoom. So TVS is a large collaboration that is growing so rapidly. It's been a privilege for Sarah and me, having been chairing for the last 3 years. By the end of the year, so in December, our 3-year mandate will come to an end. So people should maybe start thinking about if there is any interest from you or someone you know to step up and become a reference person for the collaboration. Always feel free to contact Sarah or myself if you have any question, any concern, any proposal for something you would like to add to the current structure of the collaboration. The number of members, as I mentioned, is growing very, very rapidly. I think there are at least 2-3 new requests for membership per week. This has been the case at least for the last few months. Definitely data trickling in is perking people's interest at an increasing pace. And now TVS has more than 645 members. So it's not always easy to work together, especially with these big numbers, but I'm very proud to see how people have done a wonderful job so far, and hopefully we'll keep maintaining a healthy and constructive collaboration atmosphere moving forward when all the LSST data will become available. So we pride ourselves with not just big numbers, but the diversity of people, background, social and scientific, and everything that all of us can contribute to. And Sarah and I always like to show these slides pointing to the TVS roadmap if you're curious about some of the main science cases that people in TVS care about. But the main reason why we like to flesh it out is to stress the diversity of scientific topics that people in TVS are interested in. And I'm pretty sure there are more that are not quite represented by what you see in the slides. So I expect in the next few years, even more to emerge and get more and more traction as people collaborate to do great science together. The way that TVS is structured, we have a number of subgroups and task forces. Subgroups are typically based more on a science question, on a science topic, and they last multiple years, typically in some cases from the very beginning of the science collaboration first got instituted. Task forces are more targeted. They're teams working together for a year or two, sometimes more, to try address some specific problems, specific needs. Here, I will not go through all of them in details, but it's a flash of what the current subgroups look like. They go from galactic science, such as microlensing, interacting binaries, and tidal disruption events, all sorts of galactic and extragalactic sources. And always please feel free to reach out to the coordinator of each subgroup if you want to get more involved, or once again, if you have any idea to propose. Some of the latest changes from the last year and a half, I would say, is the interactive binary subgroup that I have just mentioned, in fact, doesn't exist anymore. It got split in compact binaries and ellipsoidal eclipsing binary subgroups. So depending on your interest, feel free to once again reach out to the coordinators, let them know you would like to get involved in their activities. And it was nice to see that some of the subgroups that used to exist quite a few years ago and then they became inactive, somewhat dormant, are now back up and doing awesome work. And these include the Fast Transient group, led by Char Daniels from University of Delaware here in the room. And the Transiting Planet subgroup has restarted with a lot of energy brought by the coordinator, Suber Corley, and a lot of analysis, very useful to understand whether or not Rubin can be a relevant or even a key facility for planet discovery is being carried out. So keep watching this space. And in terms of task forces, some remain nominally active, although their intervention is somewhat saltuary, such as the Survey Strategy Task Force, since we're now converging on a certain survey strategy. There are some concerning the data previews from DP0 now becoming DP1. Crowded field photometry is extremely active, and people working in commissioning. I guess without their work, we wouldn't be here talking about so many early results during this RCW. And software is just something at the basis of the project. Once again, you have a diverse suite of software being developed. So if you're interested in what's happening or you have your own software, your group is interested in specific development, feel free to join, share what you're doing, and get help. Last year, we put out a call. What are the task forces, new task forces you would like to see? And several of the responses pointed towards AI, especially generative models, big language models, large language models. So those pleas have been heard, and in particular, Clécio de Bom, who's based in Brazil, kindly stepped forward to coordinate this new task force. This is all very new. You will hear very soon about how it will be organized, how to join, and how to get involved. In general, Slack remains a primary way of communicating within TVS. We also have a mailing list, but on Slack, one of the benefits is that you can pick and choose which channels you're more interested in getting active. And you recognize them pretty easily. Just search for TVS .. whatever you're interested in. So have a browse, go around, see what piques your attention, and just get active. In addition, this year we instituted a new committee, the TVS Onboarding Committee. As I mentioned, the request went from about once or twice a month to quite a few per week. So I cannot thank any more than what I'm already trying to do. People who volunteered to be in this onboarding committee. The role is to take all the requests for membership, review them, engage with people to understand their degree of interest, which subgroups are maybe more suitable for their science, and go through all the procedures for onboarding, which take quite a lot of time. So a huge thank you to Robert, Someye, Sayalong, and Nina for their incredible help. The other committee that we're planning to found and establish by the end of the year will be the ethical committee. It will be a pretty delicate role, very important. We'll be regulating issues, for example, related to publications and possible other problems that, of course, will always have the help from the co-chairs, but we think that having a dedicated committee will add a lot of value and hopefully empathetic but impartial judgment of difficult situations. And let's dig in the session now. The way we thought of organizing this hour and a half is after this brief introduction about TVS. We have a couple of talks about extragalactic transients in particular, and resources from Gemini Observatory for the study of the variable sky in the Rubin era. Then we will hear about updates and highlights from the subgroups and task forces, and we'll conclude with a discussion. And before moving forward, I'll be happy to take a few questions. Thank you. Any question from people online? Or anyone in the room? We have one question, and I wonder if we have, I see microphones, so I'll go get a microphone, and can I please have one person helping with taking the microphone around? Thank you, Vincenzo.
Hi, I'm Tatiana, and the question is, this new task group, the foundational AI, is going to be mainly focused on LLMs, or is going to be more like diverse? I don't know.
I think the original idea was to have it more focused on LLM, and their applications to the Rubin datasets. However, we have had some conversation among some TVS members, and it sounded like an even broader scope, including foundational models and so on, could also be fit within, so that people can truly find what they're interested in learning or applying within the task force. So there will be definitely that plus something else.
Okay, thank you.
There is a question online. I can read it. Can you hear me? Okay.
Yes, we can hear you.
Okay, thank you. So I can read it. So what are the requirements to successfully apply to the TVS Science Collaboration? I can start saying maybe, Igor, if you can share, I don't know whether you can switch to the website, but you can find on the website, I can post the link on the Slack as a reply of your question, Ishan. And there is a membership form, which is very easy to fill, a couple of sentences on your interest and on what you are foreseen to work on once being TVS member. So by submitting Okay.
We have members and roles.
Mhm.
And here there is apply to become a member. So if you go on the website, again, just Google up Rubin LSST TVS. There is this menu on the top right, find members, and you can then apply and find the form. So responding to the question, what are the requirements for a successful application? I think we would like, first of all, well, people, who are real scientists, want to do real work. So the bar to be admitted is deliberately fairly low. We want to be inclusive. You don't have to claim to do some research that for sure will win the Nobel Prize to be able to join. Show commitment. Show that you are interested in contributing to TVS science. Spend a little bit of time filling out the form. Help us, a member of the committee, understand you're there, you're committing, you want to do good work, and you want to work together with people of the collaboration. I think there is not much more than that needed to pass the bar. Sarah, do you want to add anything?
I'm sorry, I was responding another question here online. No, I think what you said, it's perfect. Again, it's a couple of sentences, and then to be successful, I can just add that, as Igor was showing, we are organizing subgroups and task forces. So you can indicate the subgroup which you would like to be a member of, contact the coordinator, and try to be active in the group, especially now that the data preview one are available. This is the time to be involved. Yeah.
Thank you, Sarah, and to whoever asked the question. Are there any more questions before we move on with the talks?
There's another question online by Katie. Is there a Google Calendar similar with regular meetings of the collaboration? Yes, there is. It contains all the TVS meeting with the proper day and hour. All the meetings, both of the TVS general meeting and the meetings of the TVS subgroups and task forces. I will put the link here.
Okay, so in the meantime, while I'm enabling screen sharing, I will invite James Freeburn to come to the podium for the first talk. Jim, would you like to share your slides by Zoom directly? Let's do that. Take it away. There we go. So just maximize that. Very good. Sorry about that. Yeah, so I'm James. I'm a postdoc at UNC Chapel Hill working in Igor's group. And over the last few weeks, we've been looking through the Rubin Data Preview 1 data to identify extragalactic transients, which will be among the first transients ever discovered with the Rubin Observatory. So this is an example of what we're looking for. This was actually a newly discovered transient that was discovered in Rubin Data Preview 1. And you can see kind of the relative depth between the Rubin data and some archival DECAM data. And in the crosshairs, you can kind of see what is a supernova. So in this talk, I'll just go over how exactly do we identify these transients,
and then go into photometric classification and comparing what our findings imply about rates. So in terms of selecting fields from data preview 1, there are 7 fields included in the data preview, but not all of them were appropriate for a search for extragalactic transients. So these 2, when you're looking for things like supernovae, you don't want to be close to the galactic plane because it's very crowded, and you also get lots of extinction. But also, we eliminated these 2 as well because they were coincident with globular clusters, so end up with a lot of variable stars, which are great for some science, but not for this. So we're left with these 3 fields, and you'll notice that one of them is very close to the ecliptic. So this something that we needed to keep in mind is that this field was going to be infested with asteroids. Sorry about the terminology. So this is the distribution of limiting magnitudes. It's actually, when you look at the median limiting magnitudes, it's fairly close to kind of the aims for the main survey of LSST. It's a little bit shallower, but I imagine in the full survey, it's going to end up being deeper. And visits, it's just every science image that was taken. So this is a typical light curve that you might see from DP1. So this is an RLI array, and you can see that multiple images are taken every night. This is probably not going to be similar to what's in the main survey, but maybe could be kind of analogous to the deep drilling fields. And you can see that you have a bunch of visits per night. And for this project, it's quite advantageous because we can kind of co-add these measurements and get a little bit more sensitivity. So with the initial query for these 3 fields, we ended up with about 400,000 objects, which indicates that the difference imaging was quite good. But I don't really want to look through 400,000 objects, so we needed to cut it down a little bit. So we placed some cuts on minimum number of detections, as well as it had to fade by about 10% over the course of the fade or rise by 10%. And then this reduced it to about 3,000 objects. And again, we're worried about asteroids. Some people love asteroids, but for this, we really needed to remove them. So, but thankfully, with the DP1 data products, there's a fairly good catalog, which has flagged already all of the, a bunch of the solar system objects. And just to be extra sure, we added a requirement for the time between the first detection and the last detection to be longer than 30 minutes. So this cut out about 80 objects, and most of them were in that low ecliptic latitude field. The next thing that we needed to address was removing variable stars and AGN. We did this by just cross-matching with the DECAM legacy survey and just removing any objects that are coincident with a source that's well modeled by a point spread function. And this cut it down to about 1,000 candidates. And now this is something that Igor and I can actually look through and identify real transients. And we ended up with 11. So this is a bit of a problem. Once we identified our transients, a lot of them were present in the templates. And the reason for this is in DP1, the templates are actually made up of science images from the actual observing campaign. And this is a problem because the kind of flux measurements that we get end up going into the negatives. So we needed some way of correcting this. And what we did was we just took DECAM legacy survey images and just subtracted them from the template to just compute offsets for each filter. And this actually kind of limits the sensitivity because the legacy survey images are a little bit shallower than the templates, but also when you have the transient present in the template, that also kind of limits your sensitivity in a different way. So once this was all done, these were the 11 candidates that we found. And these are the first light curves of transients in Rubin, which is really exciting. And we see some really beautiful light curves there. Yeah, so the next step was to do photometric classification. So we used SuperPhote Plus, which was developed by one of our co-authors, Kaylee DeSoto. And essentially, it's just a machine learning classifier that takes in features of the light curve and spits out a photometric classification for each supernova or transient. So after doing that, we got 6 type 1a supernovae, 2 type 1bc supernovae, 2 type 2s, and 1 type 2n. And the type 2n, I just want to stress, this is photometric classification, so we don't know for sure. We don't know spectroscopically what these objects are. This was likely flagged as a 2n just because it has that plateau phase. And what's really exciting about these transients is all but 3 of them were new discoveries. So the ones with stars next to them were discovered and reported on TNS directly from DP1. So these were some of the first transients discovered in Rubin, extragalactic transients. So the next step of the process was, how does our results compare to the rates that we'd expect for LSST? So we used SimSurvey and basically simulated what a range of supernova models would look like in Rubin DP1, and then saw how many are detected and how many aren't, and then scaled that to the expected supernova rates from the literature. So when we did this, we got about 34 candidates in our sample. You'll notice that that's much larger than the 11 that we found. But what this analysis didn't take into account is that issue with the templates. And I expect that that is the main reason for why our rates of supernova detection were so much lower than the predictions. But in the main survey, once good templates are generated after the first few months, this won't be an issue, and it'll probably be much more in line with what we expect. So just some key takeaways. So the good, we can very reliably identify bona fide extragalactic transients with very simple cuts. So the cuts that we did are very kind of first pass simple, and in the main survey, they'll be much more rigorous, but it's very reassuring and kind of speaks to the quality of the data products that we're able to so easily get these candidates. So another good thing about DP1 is it shows that having a high cadence, so it was almost a daily cadence for DP1, we can get very good photometric classifications of these light curves. And likely with the deep drilling fields, we'll have kind of a similar observing strategy. So that's reassuring. The not so good, as I mentioned before, is the templates were generated from the science images, which meant that a lot of our transients were present in those templates. And again, for the main survey, this likely won't be an issue after the first few months. And yeah, just related to that, our observations didn't agree with expected rates. But the main thing I want you guys to take away from this talk is that the paper will be released on arXiv on Wednesday. So go look at it. Go look at it on Wednesday night. Yeah, thanks.
Thank you, Jim. Any questions? We have a couple here in the room. Let's start from there.
Hi, I'm Shreya Anand. Great talk. I was wondering if you could comment on any follow-up efforts that are ongoing of any of these transients, if they're still bright enough. I also didn't see if you have any plots of magnitudes of these sources.
Yeah, so the data preview 1 was taken from October to December last year. And when it was released a few weeks ago. So at the moment, none of these objects are actually observable. So that's a bit unfortunate. But in the main survey, a lot of these techniques will be used to trigger follow-up, especially Kaylee's Superfote Plus code, which is basically designed for real-time classification.
Cool. Hi. So this is Sid Chiney from the University of Delaware, and great talk. My question was about the machine learning classifier you mentioned. What was that trained on for something like DP1? Because you obviously can't train it on DP1 if you don't have labels. So what did you do here?
That's a great point, and I'm not super familiar with the code, but I assume it's based on supernova models and not directly on like specific Rubin data.
Thank you.
See, we have a question online. Let's go there and then to Vincenzo in the room.
Hello, nice talk. I'm Anindo from Ayuka. So I have a questions about do you have any information about the host galaxy of this transient? Because in case of type 1a supernovae, do we have any spectroscopic redshift of those galaxies?
Yeah, so some of them had spectroscopic redshifts, but most didn't. And so we just used photometric redshifts from the kind of DESI legacy surveys to get our estimates for the classifier.
Okay, thanks. Nice talk.
There is
Thanks.
another question online on Slack. Can I go with this one, Igor?
Yeah, go ahead.
Okay, it's from Dragana for the speaker. What are the strategies for multi-wavelength and spectroscopic follow-up of the extragalactic transient task force?
So is that for these specific extragalactic transients or when we get into the main survey?
Dragana, do you want to jump in and add some details?
Yes. Thank you very much. Do you hear me well?
Yes, I can hear.
Thank you very much. Yes, I was referring more to the general strategies. So are there any coordinated actions not for these specific, you already answered that these are not visible currently, most of them, but for the future? I mean, are you coordinated with other surveys or task forces within other science collaborations and so on? Thank you.
Yeah, so the plan, I guess, is to combine the data from Rubin with other surveys like LS4 to kind of fill out the light curve in its early evolution. And then you can use classifiers like Superfote Plus to then pull out interesting candidates for spectroscopic follow-up that you can then trigger whatever telescope, like Gemini or SOAR.
So let's take one more question from
Thank you.
the room. I see that Suber also asked about the title of the paper. So maybe Jim, we can do that offline and maybe can send a link when the paper is out. We have a question from, two questions, one from Vincenzo, one from Dan, very quick.
Yeah, very quick, otherwise we can talk later. About the issue with the templates, I do understand this is something just happening now and it will be minor later. But can you comment more on how you use the legacy survey data to fix it? Because in principle, I was thinking just to add the flags that you measure on a template where the source it is. And in principle, you should be able to reconstruct the true flags, or maybe just measuring PSF photometry, the first photometry on the science image.
Yeah, the problem there is the host galaxy contribution to the flux. It's not always easy to account for that. So that's kind of the subtracting it from legacy survey images is kind of the best way of estimating the flux offset. Yeah.
Can I just ask you to go back to your slide with the list of photometric classifications?
Yep.
Yeah, so typically in surveys like this, we see mostly type 1a supernovae and 70% type 1a supernovae. So I guess remembering the small number of statistics, you are consistent with that. So based on that, do you have any estimates on sort of rates or rate evolution, or is that something you think you would be able to do with if you're able to recover more of the 70 transients you expect?
Yeah, so yeah, I think again, yeah, it is small number statistics, and these are kind of photometric classifications. So I think ideally you would have a large sample with spectroscopic classifications to actually do this in a more kind of conclusive way. Does that answer?
Yeah, just the mix of transients that you're finding is consistent with the mix you'd expect to be finding.
Yes,
and
yes.
Not biased in some way or the other, or reflective of some sort of unexpected redshift evolution or filter.
Yeah, at this stage, it's probably too early to say, but I would say that this is roughly consistent with what we'd expect in terms of the different classes.
All right, thank you, Jim. I'll conclude with a quick note, because let's remember we're at the community workshops. It's a lot about the community. So let me mention that Jim started his postdoc July 1st. So the day after DP1 started, he came from Australia, and 2 weeks ago defended his PhD and did all this work in the meantime. So please join me and give him a big applause.
Thanks.
And I will call the next speaker to the podium. So you're also going to do Zoom sharing, right?
Sorry.
All right. So the next speaker will be Sijik Su, and will tell us all about Gemini DD initiative for Rubin follow-up and all for time domain science, right?
Yeah.
Take it away.
Thank you. Yeah. Good morning, everybody. Very glad to be here. My name is Si Xu. I am an astronomer at Gemini Observatory and NOAA Lab. So very glad to be here and tell you a little bit about our new DD initiative. Once in a Rubin Gem. We need to come up with a better acronym, so please, this is just a title. I want to tell you about Gemini DD Director's Discretionary Time Initiative for Rubin follow-ups. This work, we're working closely with the Gemini chief scientist, Elena Sabi, and also our director, Scott Dunn, and many of the staffs at Gemini and NOAA Lab. I also just want to say this is a quite early stage, so we are still brainstorming the ideas. That's why this is the perfect platform. So please come find me, talk to me. We want to hear your input. All right. probably don't need for this audience, but just so we're on the same page, why are we doing this, right? And so time domain, new windows on the dynamic universe is one of the 3 top priorities in the Astro 2020 Decadal Survey. And as we already learned, Ruben is working great, and then it will be in science operation very soon. The first alert probably will come up later this year or early next year. So now is really the time to think about the community effort about how we want to best use of what will come out of Ruben science. And also here at NOAA Lab, many people have been thinking about that. For the past 2 years, we have 2 conferences. One is Windows on the Universe, another is Real Gems in Big Data, all focusing on what the community should do to get ready for this. So just put it in simple words, my understanding, we really want a better coordination and less redundancy. So that's kind of why we're doing this. So what is this DD initiative? I think there are kind of 3 key characteristics. First is we really want to focus on exploration, like new, exciting, unexpected discoveries from Ruben. So currently, the director has committed to 20 hours per semester for the next 3 years. So we'll start early next year. It's 20 hours, it's Gemini North and Gemini South combined. So depend on the type of instrument and the type of science you want to do. And we really see it as a community-led effort. So that's why we want to hear from you to kind of inform the observatory what's the best way of use our instrument. And then we want to keep the data at 0 proprietary period. So once we get the data, it will be immediately in the archive. So everybody can have access to it. And we also want to emphasize rapid. I will go into a little bit more later. Once you define the observation, depend on the nature, the response time can be as low as 6 minutes. So basically, once you trigger, we can go on sky if that's the type of observation. So I want to go into a bit more about exploration. So what exactly are we trying to do? So it's a little bit hard, and I think that's what we really want the community feedback. We really think we want to use this DD to focus on unknown unknowns. So I can't really come up with an example right now. So that's why I'm trying to say what this DD is not. Sorry if your favorite topic is on that. The reason we can't use this DD for is because all these topics, we already have existing Q programs focusing on them. Like we already have approved program focusing on interstellar objects, gravitational waves, fast radio bursts, more common type of supernova, gamma ray burst, and the kilonova. And I also just want to say, this DD initiative, it's its own thing, but we still have our regular Q program, right? Fast turnaround, regular DD. So we really want to use this DD to reserve to kind of these unknown, unexpected discoveries. Yeah. And you can find out more about what's already in our queue and in the link below. And this is our proposed timeline for this. So we're thinking, we're almost August. So we're thinking this is kind of the first advertisement in this workshop. And then there's a QR code for this working group sign up. So if you're interested, please join us. And then in September to December is our main time to gather community input. So depending on the response from the sign up sheet, we probably will organize a few video meetings and then finalize the details about what exactly is the trigger criteria, what exactly do we want to observe? And we expect to put together a white paper, say by the end of the year. So the observatory will have a chance to give feedback and then finalize some technical details and then set up the observations early next year. So the plan is hopefully by March, all the observations will be set up and ready to trigger. And I think this timeline works well with the overall Ruben timeline as well. All right, then a few more words about, next few slides is more about Gemini, about why we think Gemini is really well suited for this kind of initiative. For those who don't know, Gemini, we are 2 8-meter telescopes, and one in Mauna Kea in Hawaii, another in Cerro Porteño in Chile. So these are kind of the 2 of the best sites to do ground-based astronomy. So we have coverage of both hemispheres. And also, if you want to trigger something, there's a good chance one of the telescopes is at nighttime, right? So you can observe right away. Also, we have a very flexible Q scheduling. Actually, since the very early days, Gemini had committed a significant fraction of its time to do TOO type science. So here we're showing really from 2005, and this is the fraction of the total time. So band 1 is shown in green. So you can see since like 2005, at least 15% of our band 1 time, which is like the highest priority time, has been committed to do TOO. And then we have 2 types of TOO, target of opportunity observations. First is rapid TOO. So typically once it triggers, it will get observed within 24 hours of trigger. Of course, these kind of observations typically have very relaxed weather conditions. Kind of as long as the observatory is open, you will just go right away. So we're seeking some of the DD would probably fall into this category, and we would follow the same like rapid TOO like strategy. And then we also have standard TOO. So once it's triggered, we try to observe it as soon as possible, but typically it's more than 24 hours after trigger. In addition, I just want to give you a brief overview about our instrument. We have a very rich set of diverse optical and infrared instrumentation. So here I'm just showing the imaging capability. So this bar is this 5x5 arc-minute point of view. So we have a GMOS North and GMOS South. They're basically the exact same copy, one in Hawaii, one in Chile. They do like optical and wide field imaging. And we also have Flamingos 2, which do JHK infrared imaging. And then Flamingos 2 is their Gemini South. Then we have GSAOI, which do more zoom in like AO imaging. And then we also have fast photometry camera called Alopeke and Zorro, one in north, one in south, like relatively small field of view, if you really want to zoom in. And then we also have spectroscopy. It's a little bit complicated, but anyway, the x-axis is the wavelength coverage. The y-axis is the resolving power. And so again, we have GMOS, north and the south, which do optical and imaging. And then for higher spectral resolution, we have Ghost at Gemini South and the Maroon X at the Gemini North. If you have really bright objects, you want to get a good spectra. And then moving to the infrared, at Gemini South, we have Flamingos 2, and Gemini North, we have Genus. And then more recently, we have newly commissioned a high resolution infrared spectrograph called Igrance 2. So basically, these are all your toys. We have a whole suite of toys for you to choose from, depending on the type of target, the kind of science you want to do. So our idea is we want to predefine all these observations early, like calmly when you are thinking about it, we want to define template using all these instruments. So when an exciting science comes along, you can just put in your target information. That's all you need. Then we can go on sky and observe it. Oh, right. And I also want to advertise Scorpio, which is our new instrument, really designed for LSST coming up, and that hope to be operation in 2027. So it will be available for the later part of this DD initiative. So it can do quite a lot of things, and it's an 8-channel imager, which do simultaneous observations in 8 bands. And it also does 3 arc-second long-slit spectroscopy, which basically cover optical all the way into the infrared. So on the right-hand side is a sensitivity comparison between LSST and the Scorpio. So the bottom ones are the photometry, and the top ones is spectroscopy. And it's assuming 1 hour integration time. So photometry, it actually matches really well with LSST. So that will be a really powerful follow-up instrument once it's ready. Last but not least, observation, all these science, also we have also a lot of additional support from both software and the data reduction tools to better support this rapid response. So I just want to advertise this Aeon network, which goes from events to a decision to decide which telescope we're going to use, and then to getting new science. So we have lots of programs going on at Gemini and the NOAA Lab to support this. We have GOATS, which is a very user-friendly interface to put everything in one place. And Dragons is our data reduction tool, which will produce a reduced data product in a very timely manner. And we also have this Gemini program platform upgrade, which will make user experience much nicer. if you want to learn more about that, and I just want to advertise an afternoon session on alerts, brokers, and the follow-up systems. Also in this room, we have Brian and Monica from Gemini who will tell you all more about all this. Okay, with that, here's my summary. We are launching this once in a Ruben Gemini DD initiative for Ruben follow-up. So please join us. Again, here's QR code. I will put it in the Slack too. And hopefully I've convinced you Gemini is well positioned for Ruben follow-ups with this coverage in both hemispheres, flexible queue scheduling, a lot of instrumentation, and all our software support. With that, I just want to say thank you, and I'm happy to take any questions or suggestions.
Thank you. Any questions from the room? And as always, please remember to say your name at the beginning for the benefit of people online.
Hi, I'm Chris Walter. Very nice talk, thank you. I was curious, you mentioned that there's a possibility for very fast follow-up, like 7 minutes or something, but how many instruments are typically attached at the same time? And what is the sort of time scale if you needed a different instrument? Thank you.
Right, okay, that's a really good question, yes. Right, of course, so right, so at a given time, usually there's like 3 instruments that will be available, so it really, yeah, so I guess so as a user, usually you can check the Gemini schedule to know which instrument is there. So I would say typically GMOS is always there. And so our optical and imager and the spectrograph. And then also one of the infrared spectrograph, like Geners and the Flamingos too, are typically always there. And the rest swap in and out. So I say you do have a good understanding. Yeah, I think we do have a steady state of instruments that's there, so. But in any particular case, when you trigger, definitely check our schedule to see what's available.
Any more questions? Wow. So just 3 hands darted up at the same time. Okay, I will tour this way.
John Gizis, University of Delaware. I just wanted to ask more about Scorpio. Do you anticipate there's one on each telescope, or is this or single telescope only?
Right, so Scorpio is for Gemini South, yeah. So it's only for Gemini South, right? I should also mention Gemini South is right next to Ruben, right? So they are really kind of side by side, yeah.
Hi, this is Dave. My question is about Scorpio. How's it going?
Good. We have people here who are better suited to answer that question. So for me, I think it's currently still scheduled to be in operation in 2027. Yeah.
Do we have to put someone on the spot who's here in the room?
I'm not sure about somebody in the room. Yeah. I saw Elena is online. I don't know if you want to say something. Yeah.
Yeah, Scorpio is doing well. We had some setback in the past, but we are improving considerably. And we are planning to have Scorpio in shared risk in the spring in cycle 2027A, and then offer to the community in 2027B. So we are very enthusiastic by Scorpio. I hope this answered your question.
Hi, everybody. This is Rachel Street from Las Cumbres. Kudos to Gemini for taking the initiative to organize this kind of once in a Ruben Gem program. I think this is terrific, and I'd love to see more of this from other observatories. Have you considered, this has been done, including by Gemini, by SOAR and LCO previously. I think this would be something great to have a discussion about across universities, because this kind of program could, you know, we don't just need one telescope, and we don't just need it for one type of object. The Ruben community really needs to coordinate its follow-up efforts. And you started by saying the importance of efficiency and the importance of doing this as a community. So have you considered reaching out to other observatories about expanding this program?
I think that's a really good suggestion. Maybe we'll start within the NOAA lab. I think within the EON network, I think it's a lot easier. I think, yeah, we haven't done that. We really only put this together last week. So I'm glad, like, yeah. But right now, I think this conference is a great place to start. Yeah, so I think I'd love to learn more about it, yeah.
Okay, we have one more question from the audience.
Hi, my name is Christopher Stubbs. So I guess a follow-on to Rachel's question. This sounds great, but I think the structurally unsolved problem is flood of alerts, limited resources for follow-up. So there has to be a mechanism for choosing which things are going to be allocated follow-up resource. Does Gemini have a solution to that problem?
Exactly. I completely agree. And I think that to me, personally, I think the hardest part of this is what's the trigger criteria, right? Who decides and how we do that. So that's what we hope the community would tell us. That's what we are hoping the next few months we're gonna spend doing. But if you have better suggestions, please let us know.
I think Rachel would like to add something, but also someone online. It's very blurry. I cannot see the name.
I think Elena.
Is that Elena?
Yeah. Yes.
Okay. Elena, please go ahead.
Thank you. So we are going to have a TAC process, right? And as in the past, the community will say what they want to follow up with from Rubin. So it's true that Rubin will discover an incredible amount of time of exciting objects, but at the end, we do not expect the telescope to be flooded by these triggers, simply because there will be shared time with what is the more static universe. So we expect that at the end, we will have something of the order of 20%, possibly 30% of the telescope time dedicated to transient, but that is probably the highest it for Gemini. And it will be on the shoulder of the various observers who got guaranteed time to decide which among the amazing, exciting triggers that comes from LSST will want really to follow up with their limited amount of time. And then there are the super new discoveries. We want to observe them as soon as possible. And this is why we are trying to do this specific DD. There will be more time for more traditional DD requests that we will cover, and there will be requests from fast turnaround for Gemini. So we have a number of opportunities, but our telescope is shared also with other science cases, and the priority will be determined by the scientific community at large through the TAC.
Hello, Rachel again. I'd like to agree with Elena's part. I don't think that this is a question that gets solved by the observatories. I think this has to come from the community. And from TVS perspective, can I suggest that maybe we need a task force for this?
Fantastic suggestion. Thank
Yes,
you.
please. Yes, please.
I encourage everyone to continue these great conversations also during the breaks, later during the day. But let's thank the speaker in the meantime first.
Thank you.
Okay, so the reminder of the session will be a little bit of an experiment. So this can be easily the most chaotic part you've ever attended to the conference, because we're going to have some highlights from various groups. And we're not sure which speakers are present, which ones are online, which ones are not there. So for that reason, the slides are already on the agenda. They will serve as a reference point for everyone who's curious about highlights from TVS. And now please give me a few seconds to pull them up. And I will invite whoever has prepared the slide, would like to speak on behalf of someone who did, to just come closer whenever you see your slide on the screen. Okay, so we have to share the screen. I think, Shar, you are first. So I'm gonna start coming on deck. Yes, please. And since there are quite a few of these slides, I would ask 1 to 2 minutes, just give a broad overview, get people curious to go check out your work better.
Yeah. All right. Hi, everyone. I'm Shar Daniels, my pronouns are they, them, and I am the TVS Fast Transient Subgroup Coordinator. So as mentioned earlier this session, we have restarted the Fast Transient Subgroup after it was dormant for a while. We have a Slack channel with 64 members and it could be you. Fast transients for our purposes are just like anything that's like faster than your like typical supernova 1A. So we have a wide variety of science cases in there. And the main project that we've been working on over the last like almost year is building metrics for several different fast transient science cases so we can respond to the survey cadence optimization committee's call to evaluate changes to the survey cadence and see how well we can find this kind of fast transients with the new cadence. And yes, I will stay brief. Join us on Slack. At some point, we will perhaps have a Zoom call and like I'll introduce ourselves. And if any of the rest of you have things you would like to see from the Fast Transient Subgroup, please come chat with me this week or find me on Slack.
And I suggest if people have questions, we will save them for the end of these brief presentations. So Maya, great to see you're here. Please take it away.
Hi, everyone. It's great to be here. I'm Samaya Kakposh. I'm the coordinator of the microlensing subgroup. So we do have a microlensing session on Friday at 10:30 a.m., which I encourage everyone to be there. I wanted to mention, like, we had this really incredible sprint week in which we basically focused on developing software and simulations for microlensing, which could be also used for other science cases within TVS. What we did was that we wanted to identify what are the things within the current existing simulations that need to be improved, what sort of like other categories we need to add to that. And we also worked extensively on our software for detection and classification of microlensing events for different brokers. So we have aimed at basically producing different software for different brokers. And we over the past year, we've had a series of talks from different brokers, and we have recorded all of them. All of them are accessible, in which brokers representatives told us about like their detection algorithms and how we can interact with them, how we can basically use them for our own science cases, which would be also applicable to other science cases within TVS. We're also we have some other projects. We're looking at synergies between Rubin and Roman for macrolensing, where we have an ongoing project to inject macrolensing events into DP0 and DP1, which could also be of interest to others. And so I just want to say, like, at the microlensing session, we're going to have a hands-on session in which we are going to continue to work on our software, and we will have representatives from brokers to help us basically make sure we can implement those to the brokers. So please come and join us there if you're interested, and come and talk to the microlensing people if you're interested in any of these software and taskers. Thank you.
Do we have anyone representing the compact binary subgroups?
I'm on. Paula.
Hi, Paula.
Hi.
Go for it.
Okay, so we have formed in the last year, as Igor said, we split into two groups from the interacting binaries. So our group is the compact binaries, and it's basically our interests are cataclysmic variables, AM-CAN bands, and X-ray binaries. So we spent the last year kind of trying to formulate what our goals are for LSST, and we've come up with several projects. So we have spreadsheets that define the projects proposed by people and the ability to join. We meet on Tuesdays every other week. It's 7:30 in West Coast time and like 4:30 European time. And we welcome new people that are interested, and we're proposing to use, we put in proposals for long-term projects, and we're going to use the resources. We have a page of the resources available to us as members of LSST, and we will go ahead with our projects. And basically, they're concerned with using LSST from the alerts to identify new objects and following the rises of X-ray binaries, as well as the long-term 10-year projects where we'll be analyzing the data, especially those systems that go into low states that have low accretion changes or go into high states with high accretion, and we'll do follow-up with ground-based data.
Thank you, Paula. Next on deck is a supernova subgroup. Is there anyone online or in person who would like to talk about that? Well, if not, I invite you to check out the slides, maybe reach out to Fabio Ragosta, who is the coordinator of the group. The slide is fairly complex, so actually I can even read what it says. So we built a metric to analyze the ability to constrain progenitor mass and supernova parameters from simulation of LSST observed supernova light curves. And there is also reference to a paper that I invite everyone to check out. And there is a second slide on this topic about the development, pardon me, of a generative adversarial network model to classify and characterize supernova event by analysis of different image time series from Rubin. And stay tuned for the paper from Zampella and colleagues. Next up, I think I see Sarah online still, even if it's late in Europe. Thank you, actually, everyone on the other side of the ocean who are up so late. Tell us all about it, Sarah.
Thank you. First of all, I would like to acknowledge the contribution for the preparation of these couple of slides, the next one, by Laura Venuti and the other one by Alessandro Tramuto. So in the non-degenerative variable subgroup of TVS that I coordinate, these are some highlights and achievement, mainly focus on the activity of the star-forming region group. But for all the others interested, please contact me. And there is also TVS-NDEV channel that you can where you can join the conversation. So what we have done is developing classification algorithms for young stars and variable stars that can be investigated with Rubin LSST, also as a part of the starting point of the in-kind contribution we are just going to start this year. And in the figure, you can see that Sabina Ostamuic is leading a contribution to develop Data Preview Zero notebook to extract variability at time scales in multiband light curves, in particular to explore different time scales in young stars from scales of the order of hours to days, and long time scales on the order of months. And also with Laura Venuti, we provided input for the surveys DECAM and Roman with Rubin for the coverage of the galactic plane and the time domain. And also there is an internship ongoing of the undergrad student at the University of Palermo, Chiara Virzi, using different brokers to characterize variability of young stars. So in the next slide, thank you. This is more focused on the work by Alessandro Tramuto. There will be a paper quite soon, Tramuto et al., in preparation, using DECAM data as a precursor of Rubin LSST to detect variability in star-forming regions. In the past, we have performed the simulation to optimize the survey strategy to identify different variability in young stars due to disk occultation or modulation due to rotation or accretion burst or eruptive burst. And we are now investigating similar variability using decant data and all the filters similar to Rubin LSSD. And that's it. Thank you.
Thank you, Sarah. Anomalies, Sid.
Thank you. So hi, I'm Sid Chaini. I'm a PhD candidate at the University of Delaware. And another one of those subgroups we've been sort of restarting a bit slowly, sort of, but that's TVS anomalies. So as you might know, there is an anomaly detection subgroup in the ISSC, but the community has been very clear to us that we also need a TVS specific sort of subgroup to look at anomalies in a TVS centric way. And so Kostya and I have been working on reviving the subgroup. So we're mostly right now sort of working with ISSC AD as well. So common sessions there. But right now I'm working on starting a project related to with TP1 to find anomalies in mainly from the TVS point of view. So if you're interested in any kinds of TVS anomalies, please talk to me this week and I'll be more than happy to chat with and see what we can do as a joint project. And there's also a machine learning plus anomaly session later this week, and where we'll also be looking at a bit more anomaly related things. So if you're interested in any of these things, please talk to me or join us at TVS Anomalies. Thank you.
And we have Vincenzo coming up next.
Hi everyone, I'm Vincenzo Petrecca from INAF Napoli, and I would like to talk about the TVS DP0 task force that now is transitioning towards DP1. I'm sharing this task force together with Sara Bonito, who is online, and we formed this task force right after DP0 was released, and so we did many things trying to increase the participation of TVS in the DP0 effort. So sharing information between different groups working in different science cases, and mainly developing and working on the tutorials both on the notebook or the portal aspect of the Ruby Insights platform. And we reached many things because we touched almost all the topics that were presented in the TVS roadmap. We presented tutorials at the official DP0 assemblies. We also participated with some contribution in the DP0 Data Academy. And we presented new notebooks that were given to the community as delegate contributions. Now the plan is moving towards DP1. So you see that DP0 is canceled in this slide. The Slack channel is still called TVS DP0, but we will rename it. And so we are happy to start again with our telecons, either having biweekly telecons as we were doing before, or asking for breakout rooms during the official Ruby Science Assembly. So if you have a plan, if you want to develop a code, a notebook, some cuts, filters to analyze your data, and if you want to do this together because you think that this can benefit different science cases, please reach out to me or Sarah. Thank you very much.
Okay, so the next slide is by Clesio. Clesio, are you on the line by any chance? I think he's traveling to another conference as well, but here you find some information about the plans for LLMs as part of this new task force. So go check it out. And I think finally, we have this slide prepared by Nandini Hazra, who is based in Poland. She's a postdoc there regarding the synergies between Rubin and Einstein telescope. There has been a paper published recently that studies in great details how to go from theory expectations all the way to detectability of, for example, multi-messenger sources of various types and their electromagnetic counterpart and detectability with Rubin. I think this is one of the most comprehensive papers on the topic I've ever seen. So I encourage you to go look it up. You will find the reference here. Once again, just click on the agenda session for today and You will find there all the information. So I think we're perfectly on time. I would like, first of all, to give room for maybe a couple of questions, if any are there, to the speakers. And maybe we finish with a few minutes to kickstart a discussion that then obviously you can all bring outside this specific question. So any questions for any of the speakers from today? Or anything online?
I don't see questions online. Neither.
Okay.
Hands.
There is one question here in the room.
So I hate to do, this is a comment, not a question. It's a response to some of the comments. So I'm Chris Walter, and Jim Chang, who's in the back. We work on the IMSIM program, which you used for DP0. A lot of the organization is organized in the desk, but we do a lot of things for the project also. And so I heard, for example, from Samaya about microlensing. If any of you have a desire for high accuracy image simulations for some of your science cases, and you have people who are interested in working on it, you should come to talk to us, because we're very happy to work with you and to work and help you implement those models. So for example, if you needed to implement microlensing or something in high fidelity images and you have some people to work on it, we could work with you to make sure that shows up in the packages, or other people too. So just come talk to us if you're interested.
So at this stage, I think it's important we can organize the work needs to be done. So I think, we have so much diverse subjects. So I would think we could make a list of publication we can do. It can be long-term or short-term, but it has a goals in it. So we can more recruit people interested in that subject, maybe, some new supernovae or new binary or classification, or how the LSS performance is different from the what's simulated before, what's expected. That kind of paper can be possible. So we have more, strong goals. It can help the young people to have publication, and where you fit, how you can help. That could be really good. Also, I suggest we can make TBS subgroup channels in this meeting. So I know everyone who come here are more active people, right? Then who could come. So that's my suggestion.
So just to clarify, are you suggesting to have, for example, a Slack channel, say TVS papers, plus on top of that, maybe each subgroup can have resources, or we can aggregate? Did I understand correctly? Let's do that as soon as the session finishes. Thank you very much for the suggestion. And in the meantime, I pulled up just a slide. I imagine we would arrive with little time at the end, given the talks, all the contribution. And I was very happy to hear everyone also engaging so much with questions to the speakers. And in a way, also the comments kind of touch on all these parts. What are the lessons learned from DP1? What's there? Can be improved? What did we really learn from these data products? And then maybe I thought many of us are interested in various in-kind contributions, or in general, if you have a package, anything you have developed about its integration, possible opportunities are out there, work in progress, or do you want to bring up something that is missing? So we'll leave the floor for a few minutes for everyone to comment on these points, or please bring up whatever is closest to your heart. Vincenzo?
Hi, Vincenzo Pedreca here. So continuing to this topic, I would encourage everyone to think about every time you do some work and you need to produce some code. Of course, this is a delicate aspect because we need to acknowledge the work that everyone is doing. But very often, when you are doing science for your own science case, you are producing some code which is useful also for other people. So if we think about our scientific case as a broader community, we can have a greater impact on the science. So it would be nice if we discuss, collaborate, and maybe publish the code and share it among the community, not just TVS, all the science collaborations. So maybe this is also something that we should think about.
Since you're at it, what are the best ways to share code and make it known within the TVS framework?
So the most delicate part is to acknowledge people that produce the code. So I don't know what kind of possibilities there are to publish the code and give acknowledgements to people. The most easiest one could be to include them in the work, but maybe having a Slack channel for papers, but also code and things that have been developing might be useful. So for instance, when I did work some time ago on DP0 to the supernova rates, I wrote a code for Host Galaxy Association, which is publicly available. So again, if people need to associate transient to galaxies using catalogs, they can go to the code, which is on GitHub, and I can use it. But I think that maybe we need a page, both on Slack and on the web page, to put all these codes that are publicly available so that people can use them. Because you don't need to spend some time to create something that is already available because someone else already did it.
If I
Just
may
to
add,
follow up on,
oh, sorry, go ahead.
yeah, just a quick follow-up on what Vincenzo was saying. Like within the microlensing subgroup, we have put our code on the TVS GitHub. Like there's a folder called microlensing, and all the software that we're developing for detecting and classifying microlensing is on there, so people can use that. And we try within the subgroup, we try to make sure that whenever we're using a piece of code that is developed by a member within the subgroup, we make sure that they're like involved in the work and also acknowledged and given the credit for the work that they have done. So I think if that becomes a tradition with the subgroup, then the code, all the code that is online, available online, can be used by the whole community as well.
All right. Hi, Chris Hernandez here. Thank you both for the points that you brought up. I think that's very valuable. One of the things that I wanted to add that I think would be useful to discuss, especially for early career researchers, is a general discussion of the infrastructure that is being developed or has already been developed to handle the scale at which LSST will produce data. DP1 is a very small subset of the amount of data that's going to be accrued over the course of 10 years. And we're going to reach the point at which we won't be able to conduct an analysis on our own personal machine. And what I mean by that specifically is we can't store all of the data that LSST will produce on our local machines. So what resources are available for people to conduct their analysis? And I think that's something I'd like to see a little bit more discussion of.
Sarah?
Yeah, I would like to add a comment to what Vincenzo was saying, that I think it is worth to coordinate with a software subgroup of TVS with Alex and Fed, because this way we will be aware of what different groups are working on software development and codes. So and there are also some in-kind contribution in the form of software products. So in mixed together, DP1 exploitation and software development, also in the context of in-kind contribution, these 2 points that you were highlighting here, Igor. So maybe it is worth also to try and use this repository that I think Alex is collecting to have a resource and a reference. So maybe Sumaye, I think you were talking after Vincenzo, if I'm right. And also the microlensing group can coordinate with the software group to be sure not to duplicate the work and to have all the information available for the TVS community and not only for our science collaboration, but in general also.
Yeah, my question bounces off what he just asked a little while ago. I'm Abi Saha, I'm at Morlab. So there are these alert brokers, and how well or how efficiently is the various projects in the group taking advantage or conversing with the alert brokers to talk about optimizing the information that they would like to see from them. This is something that the group as a whole might be.
Yeah, for sure. And just by show of hands, who has interacted with at least one broker in the last few years? A good 90+%. So maybe not as a single entity, but I guess each individual group, in a way or another, is starting and will be more and more overwhelming, probably the brokers with questions. And I think in general, if there are even more efforts to coherent sort of just evaluation of brokers, I don't think is the correct word, but picking the right one for your favorite science and anything that. Exactly. So the call is always for the brokers to advertise the work they're doing, making calls to the community to provide feedback. And I think as part of TVS, we're more than happy to help people advertise what they're doing, the type of information they're seeking, and make sure this type of communication goes efficiently both ways. Thank you. I think Rachel is the person who booked first.
Just very quickly, to answer the question about the infrastructure available, there is actually a session this afternoon dedicated to that topic. So for further information, I recommend everybody go there.
And I know that there are other people who would like to talk, but we're at the top of the hour and there is lunchtime now, so I cannot keep people any longer. So thank you so much, everyone, and thanks to the speakers for the great session.